When you're born with billions of brain cells. They connect in these wonderful pathways and patterns based on the experiences that you have every day, the mothering you get and parenting from your father, the education you get at school, and that all provides the stimuli through your brains, the eyes, your ears, and other senses for the synapses to form. What lead does is that it interferes with those very delicate processes of synapse formation by simply introducing noise. So the end result is fuzzy thinking, and that lowers your IQ and also later in life, hypertension, heart attacks, cardiovascular health in general. These effects are invisible. My name's Howard Hu. I'm a professor and the chair of the Department of Population and Public Health Sciences here at the Keck School of Medicine of the University of Southern California. I trained as an internal medicine physician and a preventive medicine physician, and for 30 years, I've been leading teams trying to understand the toxicity, the sources of exposure, why some people are vulnerable and some people are not vulnerable. But in the end, it's all about its effect on people and society. It is what we call as xenobiotic. Xeno is Greek for stranger, and what this is basically saying is that lead has no useful purpose in the body. It's a stranger. It's a chemical that's not naturally present within our bodies, but it does have biological actions. It mimics another metal ion called calcium, which is an essential metal to all these different biological processes in our body. By mimicking calcium, it doesn't actually act like calcium, so it just interferes with all the different functions that calcium usually has because lead is an imposter. And one of those functions is important to the brain. Calcium is involved in the neurotransmission process, that is the chain of transmission of one neuron to the other that goes across these junctions called synapses, which is how our brain cells connect with each other. When you're born with billions of brain cells, but by themselves, they don't do anything. They have to connect, and they connect in these wonderful pathways and patterns based on the experiences that you have every day, the mothering you get and parenting from your father, the education you get at school, and that all provides the stimuli through your brains, the eyes, your ears, and other senses for the synapses to form. And what lead does is that it interferes with those very delicate processes of synapse formation by simply introducing noise so that those junctions, those connections, are noisy and fuzzy. And it also interferes with this process called synaptic pruning, which is what happens to prune away those pathways to make those transmissions more efficient. Lead interferes with those as well. So the end result is fuzzy thinking, and that lowers your IQ. We know that lead at the very highest concentrations can kill you. But even as we go lower and lower and lower and lower, we can see all these different effects, these so-called subclinical effects on different organs of the body, right down to the very lowest levels where we know it affects the brain. It also introduces some of the behavior abnormalities that have been seen with lead toxicity. Lead also amplifies oxidative damage. The known impacts of lead on non-communicable disease, children and adult brain function, adult cardiovascular disease and death, and at the higher levels, anemia, spontaneous abortion, seizures. Well, it turns out lead is one of the most studied environmental toxicants of all. Hundreds of experimental studies have been done on animals and in test organ models of humans. There have been hundreds of epidemiologic studies done in countries all over the world using increasingly sophisticated tools to measure the exposures at lower and lower amounts, using sophisticated tools to measure all sorts of cognitive functions, using intelligence tests and questionnaires that get at all aspects of behavior. And on top of that, when all of these studies are assembled, these expert groups of scientists come together, weigh the evidence, do these quantitative summaries of the evidence called systematic reviews and meta-analyses to arrive at the conclusions that we all know now have been so profoundly emphasizing lead's impact on intelligence, cardiovascular outcomes, and the things that we talk about. There's all sorts of other outcomes that are being explored, and one of the big ones that we anticipate being a game changer is the growing evidence that lead's impact on behavior actually influences violent behavior, aggression, and criminal behavior. Bone lead levels, which is a measure of cumulative exposure over time, is associated with aggression and youth for those individuals from birth to 20 years of age. And these are examples of two of the studies that have come out in recent years showing that blood levels are associated with firearm violence. There's unfortunately lots of evidence now, and this is one of the best studies, that we simply cannot treat lead poisoning and expect to cure it. This is a multi-center randomized controlled trial of one of the best agents for pulling lead out of the body called DMSA. It's a chelator agent that was done in the United States at multiple different health centers recruiting children who were moderately lead exposed. And the bottom line is that after all this chelation, there was no improvement in IQ or other measures of intelligence in these children. In fact, one of the collateral unanticipated side effects is that the children who received the chelation were significantly shorter in height, probably because the chelating agent was pulling out some of the essential nutrients and metals that are needed for growth and skeletal formation. It turns out lead exposure not only occurs to children after they're born, when they're exposed to lead in paint or in water or other sources, but in fact the exposure happens in the womb. How? Turns out that lead freely crosses the placenta from mom's blood into the fetus, but on top of that, whatever lead that mom collects in her skeleton over time gets mobilized during pregnancy and then is free to go into blood and cross the placenta to attack the fetal nervous system. We know this because lead actually collects in the skeleton where it substitutes for calcium and bone mineral. And we've done the research showing that during pregnancy, bone absorption is heightened because the mom's skeleton is trying to provide calcium to the fetal skeleton to grow its own skeleton. Out comes the lead, crosses the placenta, and gets into the fetus. We have also shown that fetal lead exposure predicts lower IQ independent of what the child's lead exposure is after they're born. Now we have to anticipate a life course paradigm where exposure starts in the womb and it's transgenerational. It can be passed on from mother to the fetus. We have to be able to prevent exposure at every stage of life, whether it's young babies, adolescents, adults, particularly women who are of reproductive age. The other aspect is that lead apparently impacts cardiovascular health. This is a study that came out recently that showed that even relatively low levels of blood lead in this large study of adults in the United States called the National Health and Nutrition Examination Survey was a major risk factor for adult hypertension, heart attacks, strokes, mortality, that is death, from these very incidents. That's very concerning because these blood lead levels are the kinds of blood lead levels that exist in many parts of the world, and there are estimates that in fact that these kinds of exposure are responsible for up to a quarter or a third of heart attacks in some parts of the world. These effects can be measured not only looking at blood lead, but also looking at bone lead, because bone lead, as I mentioned, is a measure of cumulative exposure to lead. And now we're beginning to use special instruments to measure these bone lead levels and non-invasively and safely to do these prospective studies to see how cumulative exposure will result in poor adult outcomes later in life. So these mixture of studies using blood lead and bone lead are all converging on the insight that lead is a major risk factor for hypertension, stroke, and heart attack in adults all over the world. As it turns out, adult men and women are also susceptible to the neurotoxic effects of lead. And here's a study showing that cumulative lead exposure, again measured by bone lead, is associated with lower adult cognition. That is a measure of intelligence using these scales that look at memory, the ability to vocalize, vocabulary, read, recall. These kinds of measures are used all over the clinical world to understand whether someone's at risk for dementia. And in fact, we can clearly see that lead levels are associated with worse function on these kinds of tests. Now, I also mentioned that we're trying to understand susceptibility. And here's a study showing that there are some individuals who carry certain genes. This is called their hemochromatosis gene, a gene that influences iron metabolism, that will actually make them much more susceptible to lead's toxic effects. So the graph on the right shows you the difference in curves between the wild type, which is the usual genotype for the hemochromatosis gene, and people who carry the HFE gene. That's about 25% of the Northern European heritage population carry 1 or 2 copies of this gene, and if they have this gene, the higher their bone lead, the worse they will do in these cognitive tests. All sorts of research is continuing because we're worried about lead as an oxidative damage agent affecting other aging-related outcomes like cataracts, hearing loss, the risk for Parkinson's disease, or neurodegenerative diseases like amyotrophic lateral sclerosis, and of course, Alzheimer's, which so many of us worry about as we age. Blood lead levels, from our point of view, is that we need to move towards the target of getting everybody's blood lead levels under 1 microgram per deciliter. The irony is that prehistoric man had blood lead levels that were way under that. It was probably more like 0.01 micrograms per deciliter. And it's only after we started using lead as additive to wine, lining aqueducts in the Roman times, and for all sorts of industrial purposes, including lead in car batteries, lead in solder, food cans, that the blood lead levels of the general population started to rise. But in fact, we can target blood lead levels less than 1 for most countries of the world, and that is what this message is all about. So in conclusion, we know a lot about lead's impact on the so-called non-communicable diseases. For adults and kids, impacts on intelligence, and also later in life, hypertension, heart attacks, cardiovascular health in general. These effects are invisible. You don't feel them. There's no symptoms. They're insidious, widespread. Treatment is not really an option. So the overwhelming solution is prevention.